folks, another example. I'm calling this part B. When you see written homework number 2, question 4 has some multiplication problems. So part A is similar to the previous video, whole number times a fraction. Part B is similar to this, fraction times a fraction. So different numbers here. Okay. So what we did in the previous video was we talked about the definition of multiplication from 107A, which told us that we're going to take whatever the second number is and add that up some number of times. And then how many times do we add that up? M times, right? So that's why we read this M times N. We're adding up N, M times, or you can think of M chunks of size N or M groups of N and so forth. So M of these, okay? So in 107A, strictly whole numbers. We just, and I guess negatives, right? Strictly integers, no fractions. What we saw in the previous video is, or the previous example, is that if N is a fraction here, but M is still a whole number, then we can still add up a whole number of those sizes. And the fact that we've got a little fraction didn't seem too problematic, right? So the previous video kind of went the way on the number line that we would normally show multiplication by just taking a certain whole number of jumps of a certain size. However, the problem now is that my M is a fraction, right? So if I've got M of jumps of 3/7, that means I want to add up, what my definition would tell me for multiplication is I want to try to add up 3/7 a certain number of times. But I've got to add that up 1/5 of a time, right? Or however you want to say that. That doesn't really make sense with our definition. I can't write 1/5 of this. I just can't do it, right? I can't draw. If I draw it once, that's already one of them. I can't show less than that. So the question is, how are we going to do that? Well, let's think back to what we did in the previous video. I want to first of all set up where 3/7 is. I want my number line to be long enough that whatever the answer is, in other words, this equals something. Whatever the answer is, I want the line to have that value on there. So let me, again, without really figuring it out, let me kind of reason where that might live. So if I had one full jump of 3/7, right, am I allowed to figure out what this is using like a shortcut? I can just use my definition of multiplication. So this says take 3/7 and add it up, but just once. So just write it once. So 1 times 3/7 is 3/7, right? That would be one entire jump. One whole jump of length 3/7 would get me there. I know that 1/5 is less than 1. And so I'm going to be taking a fraction or a piece of a whole jump. And so I'm not even going to quite get to 3/7. So I don't have to go beyond 3/7 on the number line. My answer is going to live somewhere shy of 3/7. Okay, so I like to kind of set that up in my head just to sort of ballpark around where the answer is going to be. So if you're the type that can't not do that calculation in your head, right? You know a shortcut, you know how to multiply fractions, you want to do some kind of shortcut. If you're thinking something like that, then in your mind maybe know what the answer is and know about where it wants to belong. If you want to use that to your advantage as you create the line, as long as the destination is okay, have that, but don't provide that information, right? Because we don't know that. We haven't said, and the definition doesn't tell us how to multiply fractions, right? So we don't know any kind of algorithm about combining the tops or combining the bottoms. None of that is in our definition of a fraction, so we can't use that. And that was not covered in 107A. So that's what we're going to develop that together. We're getting there, but in the moment, we don't have that. So I want to show, I'm going to take, I'm thinking of one jump of 3/7, and then I'm going to have to figure out what a fifth of that jump would look like. But let me locate 3/7. So similar to what we did on the previous problem, I'm going to locate this number on the number line. Let me do it a little bit differently, because last time I set up my holes and then split them up into equal length segments, which is the process. But here I want to locate 3/7. So let me create 7 equal length segments as I go, and then I'm sure that they're all going to be equal. And so I can start with a line. Let's get a straight line if I can. And I'll use the eraser. So I want to go 1, 2, 3, 4, 5, 6, and 7. So I've made 1, 2, 3, 4, 5, 6, 7 segments. Let me locate my 1 there and my 0. So as soon as I do that, I've established the hole and it's in 7 equal segments, so I can label that 7/7. Okay. I'm not going to label everything, but I usually like to label the 1 with whatever any denominator I've developed thus far. I like to label that just as kind of a little indication. And when I figure out my final answer, if I have to split up these segments, maybe I'll try to use a secondary color. And then when I do that, I will maybe label the 1 differently once I've demonstrated something different on my line. Okay, so there we go. And 1, 2, 3, if I collect 3 of those or move over 3, I can do that. So do we always have to shade it? If you want to shade it, you can. Sometimes we'll talk about in context of shading it or collecting it. But if I kind of, you can imagine if I'm starting at 0, by moving over there, I'm sort of collecting it, right? 1, 2, 3, I've collected 3 of the pieces. Label that guy 3/7. Okay, so here is where I like to use a secondary number line. I think when I did this in class, I did the secondary line up top. Let me draw the line like that, okay? So that is sort of, I'm thinking about 1 of my 3/7, right? 1 times 3/7 is 3/7. So this is 1 length of 3/7, and that gets me right there, okay? What do I want to do, and how am I going to have to do it? So what I want to do now is split, if that's 1 jump, this is 1 times 3/7 lives right there, right? I need to show where 1/5 of 3/7 lives. So I'm thinking this 1, that's sort of like a new hole that I've got. I need to split that up into 5 equal segments. The question is, what do I do? Okay, so let's say I want to do this. So if I want 5 equal segments, I'm going to strive for equal segments here. I'm going to put 4 little marks there. So let me do it this way, and then I'll ask you guys if that's a good idea, if this will work or not. So 5 equal segments, 4 marks. Let's say 1, 2, 3, 4. Looks okay, right? So this is 1 jump of 3/7. This down here is 0 jumps of 3/7, right? And so this, I've got 1, 2, 3, 4, 5 segments. So I've split this entire jump, that whole jump, into 5 segments. So this mark is 1 of those segments, 1/5 times 3/7. Okay, and you could label all of those. This would be 2/5. 2 of these, why are they 5ths? Because I've got 5 in this hole right here, so they're 5ths. Why would it be 2 of them? Well, if I move over 2, then that's 2. So that's 2/5 times 3/7. I won't squeeze all of these guys in here. 3/5 times 3/7. 4/5 times 3/7. 1, 2, 3, 4, 5. All 5 of those 5ths times 3/7. And 5 over 5 we know is 1, right? Because this hole was split into 5 pieces, but I move over all 5 of them. There we go. So that's the idea, is I want to figure out where this number lives using my definition. So we had a hole, we split it into equal number of segments, we counted or collected a certain number of them. Cool. We got that by our definition. Then we want to figure out, we want to treat that number as sort of a new whole and locate or split that up into this B value, that number of pieces. Okay. So on this secondary line, that looks good. But the question is, what's the answer, right? I want to know what this answer is in terms of my original hole, and so I need to know what it is, where it lives in the line. And so this is what I don't really need to see or want to see, is do I just sort of like aim it up there, like beam me up, Scotty, just jump up and try to guess or figure out what this is? How would I do that, right? My original marks here were 7ths, so I've got 1/7. So I know it's somewhere between 0 and 1/7. Do I just want to guess? Do I want to kind of like figure out that length right there? So I want to be exact the way I do this, okay? So this idea, the way that we did this down here is good, but what we need to do is these blue marks don't really jive or match up with these black marks, and that's a problem. We have to figure out, we have to make some kind of marks where I can see 5 equal pieces in this hole, but sort of include those marks along the way so everything matches up. So how are we going to do that? Let me erase this stuff. So this is good reasoning. This sort of gets me in the right ballpark. So I kind of know where the answer is. But let me get rid of that. And so let me draw that secondary line though. I do like that idea. I'm going to use that, but I'm gonna mirror things. I need to, basically what I need to do is show my work on the top line. So this little line down here is a visual aid for me. Okay, so that is still, I can say, one jump of length 3/7. So I think we would agree with that. Let me write that a little neater. So I've got one jump of 3/7. Okay, so I do want to split this segment up, this blue line, into 5 equal pieces. I do need to do that, but I have to make those pieces. Then I have to figure out where things are going to coincide with these things. So as I break up that piece into as I break this up into 5 pieces, that means I'm taking these 3 segments and trying to split that up evenly into 5 groups, right? So we went through some of these arguments a little bit in class together. If I've got 1, 2, 3 groups, original segments, can I do 3 and divide that or split that up evenly by 5? Does that work? No, doesn't work. I mean, it doesn't give us a whole number. Doesn't work out. If I split each one of these in half, so let's kind of step our way through it. If I split these in half, split them each into 2 groups, then I would have 3 groups of 2, so 6, right? So if I split them all in half, I would have 6. Is 6 divided by 5 any more helpful than 3 divided by 5 was? No. Okay? So right now what I'm doing is kind of brainstorming. Do you have to show all this? Show these steps? No. This is something you can think through and figure it out. But I'm just kind of trying to make it clear my thought process here. So the original 3 segments can't make 5 equal groups, so that wasn't helpful. If I split them all in 2, I get 6, but then I can't split that as well. What if I split each one of these in 3 equal pieces, right? Put 2 little lines, 2 little lines, 2 little lines. Then I will have 3 groups of 3, which is 9. Is 9 divided by 5 helpful? No. What if I split each one into 4 equal segments, right? So if I did that, I would have 3 groups of 4, which is 12. Is 12 divided by 5 helpful? No, right? Finally, what's going to be helpful? What if I split it into 5 equal groups, right? So if I take these 1, 2, 3 segments and split each one into 5 little segments, then I've got 3 groups of 5, which is 15. And then if I've got 15, can I make 5 equal groups? 15 divided by 5. And you might say, of course, right? Yeah, because 5 is a factor right there. So 15 divided by 5 is 3. So it almost seems silly to think like that. But that will work. So pretty much a fail-safe right here is to use that number and then split these segments into, so we want to split our whole into, ultimately we want to have this whole shown as 5 equal segments. But if we split each one of these originals into 5 equal segments, then we're going to have a number of groups of 5. And so then 5 will be a factor of the total. So that's going to work out, okay? So, I could pretty much do everything on the top line and the black line, but let me try to show things here a little bit. So I'm going to I said beam me up, Scotty, a moment ago, making a Star Trek reference. Let me beam myself down, kind of just translate those marks down there. Do my best, okay? So those represent the original marks. What I want to do is split each of these segments into 5 smaller segments, okay? Do I have to explain that? If it's clear, and I'm going to use a different color, and I think that helps. If it's clear, then I can hopefully get away with it. So if I want 5 segments in there, I'm going to make 4 little lines. And again, I'm going to make them as evenly spaced as possible. I want my segments to look the same size. So I've got a little practice with this, so let me see if I can, now that I'm talking about my skills, let's see if I can do it. There we go, 1, 2, 3, 4. When I'm doing this, I feel like it looks like a football to me, like with the laces and whatnot. But I've got 1, 2, 3, 4, 5 little segments in there. I'm using the red pen. Let me go at least to here, but let me go all the way down. Why at least to there? Because that's my hole. So I want to get that split up. Not doing a perfect job here, so I'm making my lines nice and thick to make up for that. Okay. 1, 2, 3, 4, 5 little segments. 1, 2, 3, 4, 5 little segments. 1, 2, 3, 4, 5 little segments. Let me show them down here as well. 1, 2, 3, 4 marks right there. 4 marks right there. and 4 marks right there. Okay, 15 little segments. With the red pen, let me relabel my whole here. Okay, so the question is, what's my new denominator? Well, I had 7 original pieces, so I'm thinking I had 7 original pieces. Each piece just became a group of 5. So we've got 7 groups of 5. 7 times 5 is 35. 107A material, any kind of multiplication of integers, we can take for granted. So if I were, so do I have to show all of that? No, but let me just make that argument that I've got 7 groups of 5, which would be 7 times 5, so 35 little pieces. If I shade up to the 1, of course I've collected all of them, and so we would have 35 over 35. Okay. I like to label the 1, and again, with the red is illustrative because now I can see, and I know some of these marks, it goes red, 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 black, right? But the black is kind of in place where red 1 would live. I'm going to call these the little red segments are 35ths of my whole, right? I would have, if you want to show them, it's not bad actually. Let me, for completeness, go through. So oftentimes I think sometimes we want to take shortcuts. We want to be done as soon as possible. So we think, oh, I don't want to write all these marks, right? It takes so long. But does it take that long? It didn't take that long, right? Sometimes I laugh. Sometimes students email me, and they'll sit down at their computer, open up their email, and they'll type out a thing and say, do I need to show a certain step in the homework? And so my train of, I'll answer them with an honest question, but sometimes my rationale is in the time it took for you to ask me, you could have just probably done it, and then you know, and then if it's too much, so what? But you know, so again, I'll say my mantra: when in doubt, write it out. It's not really that bad. And now there's no question. I can count if I want to. I see 35 little pieces. Okay, excuse me. So each little piece is a 35th. The thing is, though, let's not forget what we were trying to do. We were trying to take this whole jump of 3/7 and split it into 5 equal pieces. Okay, I see 15 little pieces, so I want to make 5 groups of 3, and I want to make that obvious. I want to see those things, so I'm going to use another color, kind of overlap these, make some of them larger, and there we go. So in other words, if I'm going to show fifths, I want to really see the 5 equal segments. I don't want to just count 1, 2, 3 and call that 1/5 of that, because how do I know that that one is, right? I want to see those 5 pieces. So let me sort of maybe shade like the top of this line green, and I'm going to make, I know that 3 of them is going to work. 5 groups of 3 will be my 15. So I'm going to come over 1, 2, 3, and let me extend that line up top with the little green. 1, 2, 3, so a red, black, the next red one, extend that line up a little bit. 1, 2, 3 little segments, extend that line. 1, 2, 3 little segments, we will extend that line. And let's go to the end to make sure it works out. 1, 2, 3. Okay? Yeah, and I'll extend down a little bit too, just to make it more obvious right there. Okay? So my colors might be blending in the screen, not sure how that's translating, but I used green right there, and now I can see boldly 1, 2, 3, 4, 5 segments making up this whole of 3/7. Perfect, okay? Now I want to go one of those 5 segments. So if I shade over here, right, that's it. That is one, so these are 1, 2, 3, 4, 5 segments to my whole jump, so they're fifths. If I move over here, I've gotten one of those fifths, so that number right there is 1/5 of a jump, so of is my x, 1/5 of a jump of length 3/7, 1/5 times 3/7 lives right there, okay? So remember, backtrack, how long is this video? Backtrack about 10-15 minutes. We kind of estimated it was right around there, right? And I drew an arrow up top, but I didn't know exactly what I wanted to call that. I didn't know what my denominator was. I did not know at all. So now I've located it on this secondary line. Let's locate that value on the top line, and then we're done. So this green mark was my 0, and then I had 1, 2 red marks, and then the third red mark became this long green thing. So up top, I've got the 0, I've got 1, 2, and then third line right there. Okay, so that line is that line right there. So I will bold that up so we can see it nice and clearly. And now I've got to label it. What am I going to label that number? What's my denominator? How many little red pieces or little segments do I have from my whole? 35 of them, right? Where did that come from? 7 segments, 7 groups of 5 became 35. So my denominator right there is 35. What's the numerator? How many do I collect? So 1, 2, 3. Let's put some little dots there. I've got 1, 2, 3 of them. They're 35ths, and so the answer is 3 over 35. Alrighty. There we go. So take some time. Take some time, some effort to make it nice and neat, real obvious. Let's see if every number, everything is obvious here. In other words, would I really have to show explanation? Write it down. And again, I'm going to kind of leave that up to you guys. In the sense that I'm gonna leave it up to you, but then when I read your stuff, if I feel like maybe you needed to explain stuff, I might say so. But yeah, think about, is everything, could someone follow this? And again, so when you draw, as you're drawing something, you know what you did step by step, but now that I look at the final picture, is it all there? Is it clear to read? So I see the 3/7, right? And I see this mark under it. So I see where 3/7 lives, and I see sort of what was going on here, that I was looking at a whole jump of 3/7. Do I see a 1/5? Yeah, I can see that thing. I see the 5 equal segments, and I see my 1/5, right? So everything's kind of on the picture right there. That mark is that mark. Do I see the 35 in the answer? Yeah, I see 35 little segments. So again, do you think it needs a little bit of writing? I'll leave that. I'll let you guys decide that. But basically, this is our process. Okay. So it's long. Again, you're saying, why can't we just do shortcuts, right? But again, we don't know those shortcuts. Who figured out those shortcuts, right? I'm not a super religious person, but sometimes I make up Adam and Eve jokes, right? On the 7th day God rested, and on the 8th day he said, here's a trick to multiply fractions, right? That's not where it came from. So people figured out the tricks by looking at a bunch of examples, maybe figuring out the long way, and then saying, okay, I see a pattern of what's going on here. Like, where's that 35 coming, right? So eventually we'll start putting those pieces together, but we can't take those for granted now. We're putting ourselves in the shoes of students who all they know is the definition. All they know is how to establish holes, break them up into pieces, collect them. And so that's really all we're doing here. So different folks enjoy different things. I think this is like fun. I could honestly do this all day long. I could just draw number lines, make fractions, piece them together, break out my colors. I mean, I kind of enjoy it. So you guys are stuck doing it. So I would say try to make the conscious decision to enjoy it, right? If you go, oh, I hate this. Why do we have to do this? I don't want to do every step. Then you're not going to enjoy it, but you're still going to do it. So instead, make it like a little game, and see if how detailed you can get, how many colors you can break out, whatever. So just like last video, I'm getting a little philosophical towards the end here, trying to push the excitement level a little bit with this kind of stuff. But to me, it really is kind of cool, and it's satisfying because again, if you did kind of outside the box, outside the scope of this class, figure out what the answer is in the beginning. You kind of halfway through the process, you're like, am I really going to find this proper answer? And it ends up falling out. So there we go.